Logo, we got a rocket, which is pretty cool with both and energy, being kind of nerdy. And so, yes, I would like to present my crew. My name is Mr. Ramirez, and I'm one of the people who were the rocket engineers and designed the rocket.
My name is Ben Whitaker, and I'm a rocket engineer.
My name is Philip Carter, and I'm the budget director.
My name is Enrique Ibarra, now as the launch director.
I'm Leah Sanders, I'm the project manager.
My name is Susie Zhang, I'm the presentation manager.
AstroNERDS was founded in 2013 to design and produce the most efficient and effective rocket in the world. We have a very specialized team of engineers that are very good at what they do. We had to consider many different things, including gravity, pressure, rocket length, and diameter, along with many other aspects to create the best rocket. We believe our rocket is the best because it was produced by the best.
Okay, so we came up with a couple of prototypes before we designed our final rocket. And so our first test, obviously you can see that there's many problems with it. First of all, the nose cone and the tail piece don't fit the body tube, and the tail piece didn't really have a place to put the motor. The center of gravity and the center of pressure were too far apart, which means that it wouldn't really fly high enough. The rocket was extremely long, which made it unstable, which we saw when we tested the simulation. The parachute was in the wrong tube, and there weren't two body tubes, so the parachute couldn't really come out when it flew, and the fin shape was too short, so that means we couldn't stabilize it as much as it could have. Okay, so for our second test, the center of gravity and the center of pressure were too close together. There was only one body tube, so there wasn't a place to safely store the altimeter, which measures the height, and the parachute, which would let the rocket land safely. And when we flew this one, it just didn't really work at all because the parachute couldn't come out.
Your final product, the Sky Eagle. As you can see, it has a parabolic nose for increased aerodynamics. It is a two-stage rocket, meaning we split the two body parts. In here will go the altimeter, and here will be the parachute, and back here is going to be your V6 motor with a 4-second delay. So when this rocket shoots up into the sky, right at the apogee, the parachute will finally eject, and it will come down safely and efficiently.
Okay, so our budget. So the total cost that our company had to spend on all of our supplies came out to be $1,152,250. Some of the more important supplies that we had to buy included a V6-4 engine. We also bought one body tube, which we cut into two pieces, the top being 5 inches and the bottom being 8 inches. We then connected those with a coupler. We also have 4 wings, which are 90 degrees apart, all the way around the tube. Our salary for our crew came out to be $46,425. This was a little more than probably most companies because we actually worked overtime hours, but it wasn't to get behind, it was to get ahead. So during the day and at night, we used our overtime hours wisely. During the day, we would meet at the end of when we ended eating during lunch or breakfast or dinner, whenever we had a break. We used our time to schedule when we had schedule what we would do at nighttime when we were given the allotted time to design a project so that we would be efficient. We also worked on the budget at night just so we could get ahead. Our total cost came out to be $1,198,675. This is $300,000 over our projected budget, and this is mostly because we made an error in our design. When we were constructing the rocket, we messed up on the body tube. We cut it too short and we could not fit everything inside. So in order to make it more efficient, we had to buy another body tube, which was another $300,000, and so this put us over our projected budget.
Alright, so clearly our extra body tube affected our efficiency, and after we did our calculations, it came out to be $10,946.80 per meter, and that's with a projected altitude of 109.05 meters. And while that is a little high, you know, it's twice as nice to have 2 rockets. So ours is better, which it does, so it has to be perfect. And so yeah, there you go, that's our efficiency. And we're going to do a skit now, and we're going to explain how we built our rocket and the types of engineering we used in the skit. Okay, this is to help you all. Is that it? Yeah, how does one happen? You know, on here? Oh. All right, now.
I don't always fly rockets, but when I do, I call AstroNERDS.
We are the AstroNERDS. We got the hottest rocket. We got enough heat to melt your hot pocket. Ah, yes.
We used rock sim to create our design. We took in great consideration into every launch.
Ah, yes.
As a team, we learned to manage a set budget for the supplies of our rocket project.
Ah, yes.
We use mechanical aspects to determine the point of pressure. We also took into consideration every measure.
Using electrical engineering, we flare up our ignition. We start up the motor for a successful rocket mission.
Ah, yes. And thank you for your time, ladies and gentlemen. I hope that you like the AstroNERDS rhyme.